Good morning. My name is John Wong. I'm with Oakwood Controls, and this morning we're going to give you a little bit of an introduction to our electronic target systems. Our company is based in Pennsylvania. All of our products are designed and built in the United States. We've been in business since 2008, and we have our root in developing sensors for military use, typically for fob protection. Today we're going to be talking about electronic target systems that are designed for live fire, small ammunition, small arms, fire both in an outdoor environment as well as in indoors. Basically, our mission here at SOFIC is very simple. The products we build and sell are basically designed to improve the probability of a first round hit. Most of our customers currently are military. Most of those military customers are operators who are in this type of environment. The types of target systems that we're going to talk about today are, this is one type right here. This is called an open air Loma bar, location of miss and hit. We also have box targets, and the way these systems work, you fire around downrange, the electronic target system picks up the supersonic crack of the bullet as it goes through the target or near the target, and then it returns information about that shot back to the firing line, and then the computer shows the hit or the miss on a screen right beside the shooter. Conceptually, what we're seeing here is a very simple example of how it works. Most of you have probably seen an airplane breaking the sound barrier. When that happens, what we call a mock cone or a vapor cone occurs, and a bullet does the same exact thing. A bullet that's going downrange at a very fast speed develops what's called a wavefront or a shock wave. That shock wave that's shown here with this very dark line, that is what our sensors is actually detecting as the supersonic shock wave of the bullet goes downrange. The way it works from a very simplistic perspective, let's assume we call our sensors microphones. When that bullet goes through or near a target, the shock wave propagates out from that bullet in a perfect circle. It's just like dropping a pebble onto a still pond. Those rings propagate out in a perfect circle, and then the microphones pick those up. And when those microphones pick up that shock wave, we basically assign a timestamp to it and send that data back to the firing line. It works very similarly to sonar or radar in terms of the mathematics that are involved. The main benefits to the system that we have are that no one is ever going down range. Where our systems are used, only the target systems are placed down range, and once the firing line is hot, no one has to go down range ever. Basically, pull the trigger, time of flight, let's say at 1,000 yards, you might be waiting about a second, second and a quarter. You look over, you'll see the shot show up on the screen right beside you. We typically use a wireless technology to get the data back. The data radios that we use are good up to about 10 kilometers. So we tell customers, as long as you can get a bullet to the target, as long as you can see the target, and if you can keep the bullet there supersonic, we can tell you exactly where you hit or missed. We can use any type of target in our software as long as what the shooter sees is the same style of target. For example, a round bullseye style competition target can be used. The precision is good enough that the scoring rings will be accurate, or in this environment we typically are using a E-target. You might notice that one of these shots is actually off the target here. That's the beauty of this technology. We can tell you not only where you hit, but also where you miss. I'm going to kind of expose you to two different targets that we offer. One is called a box target. Box target is designed typically for a pit environment or a butt system where they're going to be mounted to a lifter. And then these targets typically have sensors in corners or either across the bottom. The sensors are in what we call an acoustic chamber. And the beauty of an acoustic chamber is that there's no crosstalk. So if I'm shooting in lane 1 and there's another shooter right beside me in lane 2, we're both shooting our own targets. My target will never pick up his shots on his target. So there's a direct one-to-one relationship between the target that I'm shooting and the shots that I'm sending. They also have, by design, very high precision because the sensors are mounted either in the corner or across the bottom, acoustic chamber, no outside noises can ever affect what's going on. Also crosswinds, and the outside environment doesn't affect the shot placement as well. Typically these are used in permanent installations. What we call open air targets or LOMA targets, location and miss and hit targets, they have pretty good precision, typically bullet diameter placement within the scoring area. The detection window can be very, very large. We have some customers who are using these targets with a 30-foot wide detection window. Now the shot placement is not going to be that great 30 feet off to the side of the target. However, it's good enough to get the shots back into the scoring zone so that the shot placement will be accurately recorded. These types of targets can be put into a portable environment. Many of our customers don't necessarily own the range where they train on a regular basis. They have to share that facility with other users, so they typically do not want to leave their equipment out. So this system is very easily ported. They also can be mounted to what are called SITs or MITs, stationary infantry targets, moving infantry targets. This allows the old types of SIT systems, typically a Caswell-based system, to be upgraded to a modern LOMA technology. We've also developed something that we call an open air cube target. This is a product that's designed for relatively advanced research and development. The sensors are exposed to the environment, but because of their placement, the shot placement is very, very accurate. We're looking typically about plus or minus 2 millimeters with this product in the scoring area. In addition to shot location, we're also able to determine what the exact velocity was at impact, and that velocity is very accurate. So if you combine shot placement with velocity at impact, you're able to get some very interesting information. If you combine that with muzzle velocity, and we know the exact distance that we're shooting at, we're able to give a very, very accurate recording of ballistic coefficient for every shot that goes downrange. We have a system like this installed down at Quantico. The Marine Corps tests every single sniper rifle that's issued on our equipment before it's shipped. This process replaced a former process of having a person in a pit at 300 meters, putting up paper, scoring every single shot, measuring the shot groups, and radioing that back to the firing line. The way they test their equipment now, every single rifle that leaves there is tested simply by putting it into a fixture, shooting the shot groups, looking at the screen in terms of what the shot group size was, recording that data, and then taking the gun out and putting the next gun in. We also have a customer that has a 200-yard indoor sniper tunnel. This tunnel was originally outfitted with our box targets so that they could shoot at 25, 50, 100, and 200 yards inside of a controlled environment, basically to get data not only on weapons platforms, but also optics and other types of devices that were being evaluated. We then added a series of light screens, not only at the muzzle, but also at 100 and 200 yards. So for every single shot that goes downrange inside of this tunnel, they're able to see shot placement, a muzzle velocity, a 100 and a 200-yard velocity. They're also able to see a ballistic coefficient for every single shot that goes downrange. They found the value of this system to be very, very good. While we were commissioning it, they actually brought out a couple of different platforms to test. We had a 300 Win Mag platform with a prototype barrel and a 300 Win Mag platform with a standard barrel, and then they had a standard 220 grain Match King load that was being tested, as well as a hybrid bullet with a 230 grain bullet. What we found is that both bullets on both weapons platforms grouped very, very well. However, the one prototype bullet in a prototype barrel had a ballistic coefficient that was varying quite dramatically, even though the groups were spot on. At 200 yards, they were seeing about 0.8-inch groups or so. What they found after doing some additional evaluation was that that bullet was not fully stabilizing inside of that prototype barrel. They would have found this out later on when they were done live fire shooting outside, probably beyond 600 to 1,000 yards. But this was able to tell them very early on that they had issues. Some other pieces that we added to the software for research and development needs, we have group height and width as well as mean radius. We've also added for shooters what we call a quick view unit grid. This allows you to see on the screen very easily exactly how far off of center you are based on the minutes or mills that you've selected for your units. We've also added the ability to score zones, so you can have different types of hit zones that are reported back to the firing line. And we've recently added the capability to use thermal or infrared targets that are both either passively or actively powered. We believe this is the only platform that you can actually measure both hits and misses at night in the total dark without having someone go downrange to measure shot groups. Lastly, we're working on a project where we're taking this type of technology and putting it into a mount environment so that shooters can have a precision environment, a very realistic environment, and they can get the exact locations of hits and misses without having to go downrange again. Thanks for your attention. We're right around the corner of booth 225 if you'd like to come visit us. Again, all of our products are designed, built in the United States. As far as we know, all of our competition is based overseas. Most of our customers appreciate that. We're able to support things very well and very quickly, and we'd love to meet you. Thank you.